All right. So, boom, let's go. Hi, I'm Tom. Welcome back to another awesome PlayStation 2 homebrew development stream. We're gonna get stuff happening today, I hope, or maybe not. It's ambitious to think that anything will run today, but I believe. So we're rewriting everything to work to give ourselves a better interface into the hardware, and we're getting an interface via Lua. Sorry, I'm just gonna make sure you can actually see my mouth here as I talk. Now, very importantly, okay, and I'm gonna say this again as we have some actual viewers trickle in. I need help from my people here watching this, watching it live, watching it on YouTube later. I have played with the sync, the audio delay of my microphone, so I need people to tell me if my words are syncing up with my lips. How does it look? I think it's looking a lot better, but I can't really tell. So let's get rid of this cube. It's out of here. We're gonna head into our directory. So I streamed earlier today. Okay, this is my second stream of the day. Because there's nothing better to do at the moment except sit around and smash out some awesome code with some awesome people on a weekend. So we're refactoring everything. We're refactoring it towards my minimal Lua example, right? So the goal of this example is, okay, we can initialize our DMA and we can do a DMA transfer from Lua, right? We can set up a GS, GS being graphic synthesizer, of course. We can allocate a frame buffer, we can allocate a Z buffer, we can configure everything. This will just set up, call all of the right PS2 SDK functions behind the scenes. And then every frame, we get a GS state in. We can grab just like an arbitrary chunk of memory to use as a draw buffer. We can, a draw buffer understands what data needs to be in the buffer to indicate the start of a frame and the end of a frame. We're not going to actually draw anything yet, okay? Step one, just have the right interfaces to the hardware. And in our case, free isn't actually going to do anything, but we're going to implement this function as well. The idea is we're going to have a generic buffer interface that will work with everything. But in the case of a draw buffer, rather than I guess, a generic buffer where we may actually want to have some kind of managed memory. Say, for example, we load a mesh that we want to draw to the screen, right? The draw buffer is not really in the same class of memory. The draw buffer is something that we need every frame. We don't want to be, allocating and then freeing it, 60 times a second. So the draw buffer is kind of a special case where every time we call this, we just get the same chunk of memory back. Maybe a little bit inefficient, but the buffer interface, I guess, has a few more things in it that we saw earlier, right? And I guess I'm just saying this for my sake as much as anyone else's, right? Let's fuzzy find this file. I want to get in the habit of doing this more. Draw Lua. I need to clean up some of these unused files. So we've got this cool generic buffer interface, right? Push in, copy. We've got these in our meta table. So when we create this draw buffer, I think there's something wrong here, right? Something smells bad here, and the thing that smells bad here is the fact that this function is being used before it's defined, and we don't actually have these things. I'll probably just move all these definitions, copy the first line up to the header, right? That's the easiest way to do with this. So. Couple of to-dos hanging around. It's a little bit awkward. But in general, this is shaping up. So when I was streaming earlier, we were doing DMA Lua interface, and I think I pretty much got that finished, right? We have wait fast, we have send buffer, and this is fun because we have to grab out the length of the buffer and then divide it by 16 because the PS2 works in quad words, which are 128-bit words. That's fine. So then what do we have? What else do we have to do in min? DMA. It really is just, this is implemented, this. GS, we don't have a GS done, but I don't think we're going to actually hit an exit condition at all. I don't think, in general, a PS2 program, we're not really ever going to exit, right? If you think about it, you're playing Devil May Cry 3 on the PlayStation 2, or you're playing Metal Gear Solid 2, or you're playing Ratchet and Clank, right? You don't quit the game back to the PlayStation 2 browser. You get up out of your chair and walk across the room and you hit the reset button. because that's just how the PlayStation 2 worked, right? It's not multitasking. There's no operating system in the background. There's nothing to exit to. There is, and there isn't. That you can actually kind of like exit back to the BIOS, exit back to the browser rather. But in general, like, a program runs and it runs forever. Kind of unsure about this the more I look at it, but we'll keep it here for posterity. Actually, no. This is our minimum example. You don't need to exit on the PlayStation 2. Okay, so now what we need to do is PS2 Lua.c, right? The interface to an actual PS2 program. And so this will have, our on-frame, it'll have an entry point. Eventually, this will probably also have kind of like our global error handling function. So maybe we'll have like a PS2 error. We can just say like something went wrong and PS2 code, magical PS2 backend code will handle it. Or maybe like core error or something. Does Lua have an error function? I think it does. I don't know what it does. Actually, we can find out. Error. Okay, yeah, so it actually like, it does something. So we'd need to call it something else. Anyway, it doesn't really matter. I'm getting very distracted from the point that PS2 Lua.c. Okay, static int. So what are we doing here? We have to create a table, and that table has to have methods that we can override, but we also need defaults for this, right, in case they don't get overwritten. So the program flow will go. Main will start. It will call... it'll call this function we're about to write called PS2 Lua prog init. Yep, that's fine. And this will take in a Lua state. So this function will define our globals, such as this PS2 prog table, and it'll define it with default implementations of entry point and on frame. When we run this code, if there's nothing overridden here, it'll just do some like dummy behavior that has no real impact. And if we have overwritten them, then they'll get called. So we need this. We also need, actually this isn't static. This is decidedly not static. We also need a PS2 Lua prog tick update. Maybe let's give it like an on start, and let's also give it on update. On frame. Let's be consistent. Let's be consistent with our naming, except for this. Let's call this start instead of entry point. That's a nicer name. That's a much nicer name. Okay, so init Lua create table L. We're gonna give it like 5. I always just go for like 5 fields. That feels like a pretty safe default. In fact, in this case, we're gonna do 2 because it's only gonna have 2 things. Lua push C function. We're gonna push PS2 Lua prog entry point default, entry point nil, I guess, like an entry point function that does nothing. Lua set field. It's gonna be the field called start. I forgot I renamed this. Beautiful. Lua push C function L PS2 Lua prog frame nil. Lua set field frame. And it's that easy. Yeah, beautiful. And so then we can just like return 1. Is that everything we need? It's everything we need. So when we call this from our program, all this is gonna do is grab, well actually no, hold on. Whoa. We're not returning this. We are Lua set globaling it. We're setting the global, we're calling it PS2 prog. So this is our global table, right? Actually, I don't think we did this with our DMA. Did we do this with our DMA code? Hold on. Init. We did that with our DMA code. I need to give myself more credit. Okay, so on start, Lua, is it get global? Is that right? I need to look this up. My Lua chops, right? They're coming together, but it's bit by bit. Lua get global question mark. Lua get global. Perfect. That's simple. Okay, so Lua push string L. We're gonna get the start function. Lua to C function. Wait, hold on. Wait, this isn't what I want. We're sending this to... Wait, hold on. I want this to be a Lua function, not a C function. Is there a way to just say like call that will call both a Lua function and a C function? Lua call C. I guess the way you call a C function is by like doing it, right? So I would just say, this is actually interesting. This is an interesting thing, right? Because we could actually, so let's say Lua get table, and the table is at -2. So because this pushes it to the stack, then we push something else to the stack. So the table's at -2. This pops the top of the table. Yep, the top of the stack. Gets it. Yeah. Okay. So right now, the thing that was in the start index is on top of the stack. So can we get its type? That would be interesting. Let's jump up here. Index CAP. That's not what I want. Okay, or is it? Get. Do I have a CAPI? I'm scrolling all over the place. Standard libraries. Lua. Don't bookmark this. It is a very good page, but don't bookmark it. Get type. Lua type. Lua type. Returns the type of the value in the given index. Okay, here we go. So let in a list string T function. So Lua T function. What happens if this? I guess it's the same, right? Like a C function has the type of T function. A C function and a Lua function are the same. I can treat them as the same. In conclusion, actually, I probably don't even need to do that. Can't I just do something and say PS2 prog.start? Because this is a global. I can just like let Lua reference it. Can't I do that? Cool. Oh, cool. And Alexander results. Calls a function. Call a function. Function called must be pushed onto the stack. Arguments of the function are pushed in direct order. First function is pushed first. Okay. Let's do that. Let's do this instead. Lua call L. No arguments, no results. Return 0. Yeah, okay. I just like made that way more complicated than it needed to be. We're going to do exactly the same thing here, except we're also going to grab ooh, hold on. Because I've got this funny little line in here. And this is weird. I don't actually love this. And what I might do instead, I honestly might just say, you know, I might just stick this up here rather than making this a local. It'll be kind of like file scoped, and we can still reference this from our onFrame function, right? But rather than having some weird janky function, some weird janky state, we're just gonna track it. We're just gonna store it in a variable that everything can access. That makes way more sense. That's way less effort for now. And so that means that we just need to do exactly the same thing here, except instead of calling the start function, we're gonna call the frame function. Okay, that was a horrible rabbit hole, and I apologize deeply for my lack of Lua knowledge. Lua.h. Okay. This still may not work. So in theory, we could compile a main function here. Let's actually just stick a main in here for now. We're actually going to care about the arguments to main for the first time. So what we do, set up Lua state. We then call PS2 Lua prog init with our Lua state L. We call, let's DMA. We call DMA lure in it. We call GS lure in it to define our globals. We call the other one draw lure. New draw buffer. Where is it? Where is it? We call draw lure in it. This is a horrible name. This in particular is hankering for a refactor. As soon as it works, I'm going to jump in and actually fix that. Okay. Just lure in it, draw lure in it. So once all these things are started off, we say PS2 lure prog on start. Then we say while now this is a good one as well. In PS2 lure prog is running. We're gonna have a thing here. We're gonna have a way to indicate. So for example, again, say in our minimal viable example, this is not required for a minimal viable example, but say in our frame we have if something, then PS2 prog.finish or close or run equals false or something like this, right? The ability to say stop running this program. We're done. Exit the main loop. But like I said, not part of our minimum viable product. So while PS2 lure prog is running, not part of our minimum viable product, but we're gonna put the skeleton of it there in our C code so that the right shape is there, the right feel is there. It hits the right note in here. Okay, so while this program is running, we call PS2 lure prog on frame. And we're going to copy a few other things from our old main file as well. Okay, we're going to look at our main loop, right? Pad frame start, pad poll, important things. Not important right now, not for a minimum viable product, but we're going to need to grab those eventually. DMA wait fast. Yeah, let's DMA wait fast. Wait, no, hold on. We can do that from our script. We don't have to DMA wait fast. That is actually a little bit too specific. DMA channel. So this is what we need. Draw wait finish and graph wait vsync. This is going to assume that we draw something every frame, but like, yeah, if we're not drawing something every frame, then something has gone horribly wrong. Cool. And then there's just like a bit of garbage down here that we don't need. Perfect. And maybe eventually we'll have some like timing logic so that we don't run too fast. We'll try and actually hit, exactly 60 frames a second, no more, no less, or something like this. But for now, we're just going to spin as fast as we can. We're going to call as much stuff as we can. I really hate this. To do better abstraction for draw lure star. It's a bit of a problem. All right. The other thing here is this function isn't actually called this, but I'm going to go and make it this. Source gs lure.c. gs init. No gs init. Where did this go? What did I call this? gs lure init, sorry. I'm close, but I'm not quite as close as I need to be. Okay, so we've got to define headers for this stuff. Oh boy, we got to define some headers. We also have to actually like do the lure stuff. I think I did this in here, right? Or did I put that in a file called script.h? File load buffer. Oh yeah, I forgot about this. Yeah. Okay, so script. No, source script.c. Yeah, okay, we're just going to copy this. Draw state init, no thank you. Okay. Yeah. Load file, pickle. This is all familiar. What's the difference between call and lure p-call? I can't remember. Calls a function in protected mode. What's the difference between any error p who catches it, pushes a single value onto the stack, returns an error code? Okay, this is actually what we want. Where we had Lua cool before, we need to change it to Lua p cool. Remember that. It's getting stored in my brain. I will probably forget. Okay, so Lua state, new Lua state, blah blah blah. We are gonna go back to PS2 Lua. We are gonna set up our Lua state the sensible sane way. L is a new Lua state. Return -1. Lua open libs. And then yeah, we initialize our own libraries. So this is initializing the Lua standard library. This is initializing our libraries. Did not mean to highlight everything there. Perfect. Perfect, perfect, perfect. Let's just make sure there's nothing else weird we've missed. DMA stuff. We can, yeah, that's fine, that's fine. So the only thing missing is actually loading a file, right? We've got to we've got to load a file in here somewhere. Because otherwise this is just going to go through. So we can compile and run this for now. That's fine. But it's not going to do anything because, well, we need to implement these functions real quick. Static int ps2 lua prog start nil. Just kind of our dummy functions that don't do anything. Return 0. And we're going to have exactly the same thing. But in this case, it's going to be for frame. Just returns nothing. Perfect. Perfect. We need to come down here. Lua cool, Lua p cool. And this has a slightly different, this has an extra argument. Script.c p cool. Yeah, that's fine. That's fine. Cool, 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 cool. Okay. I like it. I like it. I guess we should actually like handle this error as well, right? So what do I do over here? If rc, let's do it. Let's do it. Int rc. So this is saying if there's anything on the stack at the end of this operation, grab it off the stack, log it, and carry on with your life because life is too short to care. Okay. So we want to compile this. We want to just compile PS2 Lua. We want to just compile. We want to basically compile everything we've got open here, right? So DMA Lua, Draw Lua, GS Lua, PS2 Lua, no script, no main, no min. Just the Lua family. Just the Lua family. A Lua family reunion. This is going to be great. This is going to be great. Also, just while I think of it, let's just rerun ctags so that we can, for example, PS2 prog. We've actually got our new functions in here. I'm going to have to remember to periodically do that. I should probably bind it to a Vim key, right? Like leader C or something. Man, I love when you leave the tea bag in a cup of tea and then almost make an ass of yourself on camera when it splashes tea out of the cup at you. Oh, the joys of having a beard. The joys of having a beard. Cool, cool, cool. So, we're getting really close to getting this to run, okay? I need to also check which headers are in script.h, because yeah, these ones, these little extras, right? I don't know how to pronounce this, right? Laulib? Lua extension lib? I don't know why it's Lao versus Lua. This tripped me up for like 5 hours when I was doing this the first time. We also need to include log.h. We need to include gslua.h, which doesn't exist yet. We need to include dmalua.h, which doesn't exist yet. We need to include drawlua.h, which unsurprisingly does not exist yet. So let's head over to gslua and let's. I don't actually think we need gs.h. This is the funny thing at this point, right? I think we've actually just completely outgrown our old abstraction. This is so much simpler, and it's bizarre. It's actually strangely refreshing. Given how gross the old main file was, this is going to be so much cleaner. This is such a better way of working. I wish I'd done this from the start, but I think I had to burn through 8 episodes of doing it a weird way before I could get to the good stuff, right? Before I could realize, before I could see the light. I think one of these structs I stopped putting the word struct before, but that mustn't have been in this file. Okay, lua.h, I think we're good. Do we have any? Yeah, so we need to include graph.h, include draw.h, maybe include gspsm.gsgp.h, maybe. God, these headers have really eclectic names. Okay, DMA. I don't think we need DMA tags. So we need draw and we need graph. Maybe that's it actually. Let's grab int types as well, just for safe measure. So graph, draw, int types. Where does source gs.c? DMA tags. Okay. The other thing I was showing off before, and again, I'm still really excited about this, right? PlayStation 2, PS2 SDK was the ability to just arbitrarily search for things. So I can say gs psm, and I can find where these are actually defined. So what header is this? This is gspsm.h. Okay, I need it. psm.h. Because I'm defining a whole bunch of constants here. Even if I'm not using them yet, I want these defined now because these are actually going to be super important. Once I get to playing with these different image formats, oh man, it's going to be so exciting. I cannot wait. It's going to be one of the most fun things, packing images together, like overlaid in the same portions of memory. I'm really excited about it. Okay. This is going to horribly fail with a million compile errors the first time I run it. I guarantee it. But we're going to see what happens anyway. So, source. Do I actually just want to put... Do I... Okay, I'm gonna cannibalize lua.h. All this draw state stuff, it's gone. It was pretty bad. It was a janky abstraction. gs lua.c. We're going to run in. We are going to put this in here. We're going to head over. We're going to do the same thing for the DMA initialize function. And we are going to jump over. We're going to do the same thing for our weird draw lua in it, which I'm not a huge fan of, but we'll fix it later. This, of course, has to include lua.h. Now, what else do we need? Probably nothing. This is actually a really clean interface because it just puts everything behind lua. It's weird because like before when we had our GS init code, we had to like pass information into this, right? We had to kind of care about the shape of this, but now Lua, our Lua interface, our Lua glue code has shouldered all of this complexity. These files are ugly, but they make the C interfaces a lot cleaner, which honestly was like one of my big gripes with the old code. So maybe this is just going to be beautiful and simple and work. Okay. I'm getting very excited. Let's check out our make file. So, let's just redo everything. So our object, we're just gonna grab PS2 lua.o, we're gonna grab GS lua.o, we're gonna grab DMA lua.o, we're gonna grab draw lua.o. We need to go into PS2 lua. We need to get rid of these includes. We're just going to include this awesome file now, which does everything called script.h. And we are going to... oh yeah, I need to make this as sudo, don't I? I need to run this as sudo. So sudo make docker elf. And we have a million errors. Okay, this is good. So, this is what we expected. Ideally... ideally I would have a good way to like just view this whole log. So what I'm gonna do, okay, because I have this cool file I wrote called indirect. I don't remember if I ever showed this off on stream, right? But this just listens, and if I give it a make command, it just runs make. So what I can do, okay, I'll come over to this window. I'm gonna do a small terminal so that I can see more errors. Unfortunately, it'll make it harder for you to read, make it a lot easier for me to read. We are gonna go sudo python 3 indirect. We're going to run this on port like 8099, and now what I should be able to do is curl, not curl, sorry, nc, wait, hold on. How do you send a, can you do that with netcat? So let me do it outside of him first. nc 8099. I can't remember how to do this. Port. Can I just go like 0.0.0.0 8099? God, I can never remember the frickin' command line syntax. nc hostname port, right? Okay, there we go. Oh, and that actually sends it back. Oh, so I'll actually get it in Vim. Okay, that's smarter than I thought it was. Okay, so what I do, can I echo make docker elf? Can I pipe into it? I can pipe into it. Okay, so if I open Vim, I can bind leader B for build, that makes sense, to, I go echo make docker elf piped. Can I pipe like that? Do I have to escape this on the Vim command line? I can't remember. nc localhost 89 enter. Yeah, okay, this doesn't work. Vim script escape terminal pipe character question mark. Vim script. It's something like pipe, right? It's mapping key. Let's key notation. IMAP. Where are we? Bar. This is it. The bar character which other needs to be escaped. Bar. Okay, so now if I do this, I get it in Vim. Unfortunately, we don't jump to error, which isn't perfect, but we can build in IDE now. That's good. Or in editor. So L undeclared. L undeclared. Oh, this all comes to standard out, doesn't it? That's why Vim doesn't pick it up. Hold on, wait, I can do this. Not standard equals. Can I do this? I guess I can't do this. That's fine. Don't mind me. Okay. Apparently I don't close that properly, so it doesn't like the port. So if we build, that was a fun tangent. I'm glad I did that. The joys of having something that requires sudo to build. Okay. PS2 lua.c. We need to include graph and draw. First off, line 24 reaches end of reaches the end of a function without returning something. Okay, so PS2 lua.c, line 24, return 0. Nothing left on the stack afterwards. We need to include draw.h, include graph.h. And now if we build again, looks a little bit better, maybe. Lua.toString, L undeclared, PS2 Lua 48. Oh, that's right, that's just because we're using a different name, that's fine. Lua pcool undefined. Now that's interesting, okay, because I can very clearly see here, Lua pcool. This function exists. This function very definitely exists. So, y lure p call. And we're including literally everything. So I might just change this to call for now, I guess. And then comment this out. Again, I want to get something working, right? I want to get something working. Unused variable RC, that's fine. Extension of macro lure cool. Void value not ignored when it ought to be. Oh, we're passing in an extra thing now. Oh, that's annoying. Cool. So, wait, how many arguments does this have? 0, 0. Unused variable RC. Void value not ignored where it ought to be is weird. This has to just be... Oh, it's because it returns a void. Yeah, that's fine. That's fine. We can ignore this. Didn't mean to hit escape there. Okay, so. Not to be. Wait, what's... Oh, this is actually an error. Okay, no. That's fair, that's fair. That makes sense. If you try and assign something to a function that returns a void, C is like, what the hell are you doing? That doesn't make any sense. That's absolute nonsense. Okay, just some lure mistakes here. This is good. This is good. Lure set global. That's fine. Unused variable st we can ignore. Graph set background color. Yes. Okay, so 121 and 150. Let's start there. GS. Well, of course, I closed everything. GS lure 121. Why did graph? These are all graph. I don't know what happened to my brain when I was doing this. I think it was quite late when I was working on this, right? Graph. Okay. Now what? Now what? Line 150-ish. We need to actually give it the lure virtual machine, right? I need to pass in a lure thing so that it knows what it's doing. This is just a typo, that's fine. This is the same unused variable as before. 92 zbuffer t has no member named width. That is interesting, because I'm pretty sure it does. Let's find the definition. Zbuffer t. Huh, wow. Actually does not have a method called width. Enable method. Okay, so we just get rid of that. I instantly forgot what line that was. GFAF, graph mode field, graph disable. We should probably actually also bind the different video modes, right? That's kind of important. Okay. That'll be good, that'll be good. Okay, so. You don't exist, you don't exist. What now? Looks like we're on to the next file. Or not. Hold on. No return statement. Unused variable, unused variable. Hold on. ZB. Wait. With height. Get fields from zbuffer argument. Yeah, so these are never used, right? These are never used. So we actually don't want to do this. Oh dear, hold on. Why am I popping here? Push string, get table, to integer. I don't need to pop. I am over popping. I am demolishing this stack right now. This already pops. What am I thinking? Wait, does this pop? Or am I going crazy? Does calling to integer not pop off of the stack? It doesn't. Yeah, the two functions don't, hey. Because they just use that index. Man, wild. That is a wild part of the API. I don't know. Maybe I'm wrong. Maybe I'm wrong. We'll find out very shortly if this self-destructs. No return statement, line 81, and then yeah, unused variable, 81. Return, it's actually really important that all these functions return something, otherwise Lua's gonna, I don't know how to nicely say shit the bed. Line 90. The state is unused, so why don't we use the state? We probably, oh no, we just create it. So yeah, then let's just create it. Cool, so beautiful. Now we just have a few, oh well, we're not actually including the Lua header here. That's easy to fix. DMA Lua, include lua.h. We also now need to look at what our old main had. That's really annoying. So we just need to like copy these two things basically. Cool. Now if we build, oof, oh dear, that's a few errors. Too light user data. Do we not have a distinction between functions? Is that to user data? If value is light user data returns its pointer. Okay, yeah, so actually it's just user data. We just get rid of the word light. And we're probably going to see this happen again. Okay, so DMA Lua. Implicit direction of DMA channels send normal. That's weird. Main.c, please. DMA send. Let's actually just search for it here. DMA send normal. DMA channel send normal. DMA channel send norma. There's no normas here, okay? Only normals. DMA wait fast. Conflicting types for DMA wait fast. Because I have defined... Oh, I've clashed with the name. Oh, what do I call this? What do I call this? Let's just call it wait. Let's just call it wait. Let's just have a long wait. And then we bind it to DMA. This is actually important to fix. This is actually really important to fix in my mind. Oh dear. Oh dear, this is... Oh, hold on. No. This is easy. This is easy. We haven't opened it yet. Draw lua.c. Oh, no, hold on. Okay. Well, let's clean up all of these light user data instances. You're fine. You're fine. You need to go back here to user data. Yep. Cool. Okay. Push user data. How do we push user data? Is light user data, is user data, new user data. Push light user data, there we go. Push light. Okay, get meta. I haven't, oh, hold on. Well, this isn't even an extension function. There we go. Push integer. Yeah, and I need to just look and make sure that I'm actually passing in arguments to things. Okay, so. Push light user data. I instantly forgot what I was just looking at. That's right. Lua L. Cool. And now, yeah, we go line. Where are we? Ooh, makes integer from a pointer without a cast. Ooh, hold on. Maybe I do want the maybe I do want the other version of this. Wild. Cool. So, sorry to if anyone has typed anything in chat, by the way. It looks like I have disconnected from my own chat. So I'm trying to resolve that. Lua L get meta table. This is a function. The problem is I need to include allow libx. Or what's it? Allow xlib. What's it called? Allow xlib. Man, yeah, it really looks like I just cannot connect to my own chat right now. That's very unfortunate. If there's anything desperate, you have to tell me. Anything desperate you want to tell me, you'll have to message me on Discord. Okay, so if we build this again, we're getting errors. We're getting fewer errors. Okay, we're getting there. Line 132, that's important. New draw buffer defined but not used. That's weird. That shouldn't happen. 132 unused variables we can ignore. That's fine. It's weird, but it's fine. 132, 116. 116. Beautiful. I'm guessing there's going to be more nearby if I've done it. End frame. I think this is a bad copy and paste job, right? Oh. Huh. It looks like I've lost connection to Twitch TV. Oh, it looks like I've lost Wi-Fi on my laptop. That's what's happened. Oh boy. Let me pull my chat up. Hilarious. I don't know why this happens on my laptop sometimes, but so be it. Okay, sorry. And sorry to anyone watching this on YouTube later for the small Twitch-related tomfoolery. So I think what I did here was copy and paste, right? We don't need this. Continue to point plus head. This is good. Draw finish. Head equals, yep. Sure. That sounds good to me. I think this might have a logical error in it, but we'll find out. Draw Lua, new draw buffer. Weird. Unused variable size. What's this? 98. Oh yeah, because we're getting size, but we're never actually using it. Let's just comment it out for now, I guess. Warnings are bad. We definitely want to use that eventually though. Assignment to int. This is weird. Q equals draw finish Q. We're doing this already. I don't know why this is. Oh, it's because I don't have a type for keyword T. It doesn't know what keyword T is. So if we have a look, where does this come from? I think it comes from. I was gonna say tam types, but maybe not. Oh, we can find out. Hold on. You're defined in tamtypes.h. I knew it. I should have trusted my gut. Include tamtypes.h. I don't know what tam actually stands for in this context, which is fun. Assignment to keyword T from int makes pointer from integer without a cast. Implicit. Oh yeah. We still need to include draw.h. There we go. Beautiful. We've got this error a few times. We've got this error quite a few times, starting from about line 105. We need to actually give this the Lua state to work from. Cool. This looks excellent. Let's do a quick pass here and just make sure that everything is good. Okay. How many errors have we got still? Okay, we've got quite a few. Okay. We've got quite a few. Oh, we've got a stray format specifier. This isn't good. We can do better than this. We're doing this again. Hey, I just scanned for this in my head and I didn't notice. I think the format I think you double your percent, right? And it works its shit out. Push string 97. We're still doing this. We're still doing this. I missed one there. Push integer. Okay, let's just real quick lua push. And just make sure that every single one of these has the state in the thing. Push user data. There's no such thing as push light user data. You just push user data. Push, 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 push. Oh, hold on. I missed one. I lost focus for a fraction of a second, and I almost launched the nukes by mistake. Where are we going? L. Yeah, this is good. This is surely, like, each one of these errors is like 3 lines or 4 lines, so surely this is like why that was so huge. Okay, this is still a lot of errors. But it's a lot better. Draw law. Okay, yeah. So new. We need to just move a declaration of this to the top. A forward declaration. Let's see. Lua push user data. Did you mean Lua push user? Did you mean? Did I mean that? Wait, I literally just did this, right? Push light user. Yeah, hold. Okay. I got confused for a second there. You have to push light user data. But you pop just like normal user data. You don't discriminate there. Invalid use of undefined type struct GS state, because we need to get this from GS lua.h. So include, let's just do this the dumb way for now. We're going to move this declaration into script.h. We're going to include here script, nope, source script.h. Okay. DS, yeah, this makes sense because this is a bad copy and paste from our old main function. This is fine. Draw lua ds. Yeah, here we go. So this is st, right? Or is it? No, we don't have this in our state anymore, right? We have to just... This will fail as well, right? There's no width and no height in our state. So in other words, if we go back to script, we have to do something else here, right? We have to pushing straight get table L2 lua push string L width lua get table L2 int width equals lua to integer. Right, we need to actually get this from the table, not just from the actual state. And maybe I should just put the width and the height in the state as well. Maybe like duplication isn't actually the end of the world here. Let's push string L2 int height equals lua get table L2 height equals lua to integer. Okay. Yeah. And then I just need to come in here. And yeah, this is a little bit weird because the width and the height don't come from here, but the clear stuff does. I don't know. It feels a bit weird. This is unused variable half height. So that's because I deleted one too many characters because I'm looking at this right now, right? I can see where these things are used. Oh, we actually built. We just have warnings. Okay. This is weird. I don't know how this happened. Line 85. We need to include something for malloc. And that's it. So, include std lib.h. What line was that? Did I say 65? It was a push string where we're like passing it the number. Yeah, whoa. How do we go back? I can never remember the like search backwards. Width, height. There we go. Okay, now we're getting some unused variable size. This is fine. We're not actually bounds checking our buffers. This is okay. And then we're also just not using our state somewhere. This is good. So let's see what happens. Make run. Oh boy, does it ever crash. Unhandled page fault. So we're trying to read address 0. I think. I'm guessing this is what happens. And so what's funny is this seems to have actually been fixed since the last time I was streaming this, right? In the last month. Trying to do this, trying to read address 0, was freaking out. It was crashing all of PCSX2. Oh, maybe it is. I don't know. I don't think I was getting a good error like that last time. So anyway, this is good. This is good. How do we work it out? How do we work out what's gone wrong here? One option is to step through it in the debugger, and I think that's probably what I'm just going to do, right? Make run. No, don't stop the program. Wait, how do I get in and... That's a bit of a doozy, isn't it? How do I... Okay, here we go. Ignore. And there it goes. Weird. Okay, maybe I just have to like show debugger. And I don't actually get... Okay, can I just like run an elf, test elf? Yes, I want to stop the program. And then it's going to crash me. Okay. How did I do this last time? How did I step through this before? Did I just like put a delay at the start or something? Weird. No. Source makefile. This should be good, right? This is just building this stuff. So what if I come into just like really simple PS2 Lua and I say log info startup. And then I come down and I say log info finished Lua state setup. And then I say while one loop forever. Just do a big dumb infinite loop. And that has done a little error. Because there's no function called loginfo, it's just called info, because we're a little bit inconsistent between how we send information and how we log errors. Okay, that's fine. Oh right, yeah, sorry, I've got it twice. Thought I was going a bit crazy there. Okay, perfect. Make run. Yeah, nice. Okay. So it's going bad. Yep. So what I think I can do, right? If I show the debugger and I pause, can I go and put a breakpoint on main, and then when I rerun this, will it actually will it respect this breakpoint? Okay, so what I'm gonna do, I'm gonna put a breakpoint here. I'm gonna come in. I'm gonna say, shit, I can't actually. Okay, so I've got to. Can I do that? No, I can't. Okay, we're gonna just run PCSX2 freestanding so that I don't have to worry, because like, if I run it from Vim, I can't then just go into Vim and change stuff and recompile. Okay, so run elf. We're gonna run this. We are going to break. We're gonna go into main. We're gonna put a breakpoint here, and now if I recompile this, let's go into PS2 Lua. Let's get rid of this big dumb infinite loop. If I go into PCSX2 and rerun, we don't hit a break. We don't hit our breakpoint. Or rather we do. Okay, hold on. What I need to do is, because I can actually see this now. Once I hit OK, it's going to close, but I can see. This is where I put my breakpoint before. The main function has moved. So hopefully it's a deterministic compile, and if I put a breakpoint at, hold on, let me make a note of this. If I put a breakpoint at, where are we? Let's go 1591 F8. Okay, this is the address we need. This is gonna quit, but now I've got a magic formula for how to make this work. Actually, let's move you back to window 8. That's where we need you. So if we go copy dist test, and I copy it to like, and then I come back in here and I do this, and I rebuild. Okay, here we go. Here's a funny thought, right? This is extremely stupid, but it's gonna work. So we're in dist. I can run test, and this has the infinite loop, and so it doesn't hit the code that makes us crash. And so I can come into here, I can show the debugger, I can come to this address that we know is like the problem address, right? I break, I find main, and I just go down a little bit further. Right? It looked like the main for this other file, for some reason, was located just a little bit further down, okay? It isn't here. So what I want to go, 1591 F8, 159, oh, we're actually right here anyway. 159, 1 F8. Okay, that's in main anyway. Perfect. So now if I run elf and I run this other one that we copied, we're going to hit this breakpoint before we crash. That's important. That's really important. So first thing we do, right, we hit this breakpoint. Perfect. And we can just step over some stuff. This first printf is going to come out fine. It says startup. That's here. So then we do some Lua stuff, and this should all be fine, because we're going to get to our next printf line. Step over. Lua open libs, that's fine. Init, this is all fine. And then we're going to hit our next printf. Finish Lua state setup. Okay. Okay. And then we go to, yeah, draw Lua init. So this is where I think everything's going to go bad. If we step into this, draw Lua init. Okay, so we're going to follow along here, right? Wait. Whoa. Oh, hold on. I should have put this after draw Lua init. Let's see what draw Lua init does. Step over. Load. Cool new meta table, that's fine. Cool create table, this should be fine. Do some argument manipulation. I think that was a weird concatenation of, I don't even know what that was. Okay. That's what looking at assembly does to your brain, guys. Lua set field, this is all fine. Push C closure, this all looks good. Set field, again, none of these things should be able to crash our program, right? What I'm looking for is a jump to 0 or something that's gonna like dereference memory, but I just don't see it. Oh, never mind. There it is. Hold on. We're loading an address that doesn't make any sense. Are we? A1. Ah, crap. I got confident. I started talking. Okay. PCSX2. Let's rerun it here. Let's just like wipe the screen clear. Show debugger. Can I just put I can't put a breakpoint in until we're running a program annoyingly. And I'm pretty sure it'll forget my breakpoint. Yep. Cool. So let's run elf. It's annoying that we have to do this. I wish there was a better way. Show debugger. Where are we? 1 break main. What's our magic number? 1591 F8. 8. Here it is. Now we go in, we run our other elf. Beautiful, and we hit our breakpoint. Okay, so step over, step over, step over, blah, blah, blah. What we really want is draw lure in it. So actually our magic number is 159268. Step over, step over, step over, step over. Oh crap, I went one too far. It happens so quick. It's so easy to do. But now I actually know like the proper correct address. So same tedious process, okay? We're gonna break. We're gonna go to 159.268.268. So this is into a different function in this version of the elf, but whatever. We just have to load whatever elf and then we're good to go. Okay, so step into. Now, things went weird, okay? And it's quite late into the function, so it's hard to know what A1, A2, and A0 actually represent without doing a bit of legwork, which is annoying. Okay, so it's after this call to set top, right? I don't know what set top does. It's down here. It's down here. So this was fine. This is fine. Set global, sure. Set top. Okay, so it's after that set top. So what does Lua set top do? Set top sets the stack top to this index. So Lua set top. Oh. Okay. I have to step through one more time, hopefully only one more time, and work out what happens in that set top call. Man, feature request for the PCSX2 guys out there. Let us put a breakpoint in without having an elf running. That would be cool. Where are we? 6.8. This is fine. Then we're gonna run an elf. Maybe there's a way to do it and I'm just dumb, honestly. Wouldn't put it past the PCSX2 devs to have thought of something like this. Fantastic piece of software. You know, I'm just out here talking crap because I'm frustrated about what's going on here. So it's this line, right? So we're heading in. We're gonna step into this call. Okay, so set top, what are we doing, right? So we've got a couple of things on the stack. We've got a couple of things on the stack. We're loading from A0, right? So what is A0? A0, we're loading relative to A0. A0 has some address. And we're loading the 48C. 48C? Yeah, the third thing in that array. I'm guessing this is our Lua state, right? We're getting a field from our Lua state. Something, push something. BLT, what is BLTZ? MIPS BLTZ. Branch on less than 0. There you go. I don't know my MIPS. I don't know my MIPS shorthands. Okay, so BLT A1. So do we branch here? Oh, we branch here. Oh boy, do we ever branch here. We branch all the way down. Okay, I don't know what that is, but sure. B, and then we jump back, yeah. Shift left, logical. V0, A2. What's in V0 here? We haven't put anything in V0 before this, so I don't know what value V0 would have. Do we pass? Because A0 through A3 are for argument passing, right? So what was in V0? It's some address, but like, how do we know what's in V0? Oh no, sorry, we shift into V0 from A2. But what's A2? This... A2 0x3. So what is A2 in this case, right? Because it looks like this function only has 2 arguments. Maybe it, well no, but it can't. So that's weird. That's weird. Isn't that weird? Isn't that weird? So when we step over this, v0 is gonna get some garbage in it. Some garbage shifted 3 bits to the left, but garbage nonetheless. Branch equal to 0. A2, well this is not gonna branch. I'm gonna say add something. So S0 now is kind of infected by this. Oh no, I can't remember. Does this only happen if you actually branch? Anyway. So we load something from A0. So again, this is getting a field from our Lua state. I don't know what see again, SLTU, what's this? MIPS. SLTU. Register greater than instructions. Real hardware instructions. Set if less than instruction. Okay, unsigned. Sure. So what does this set v0 to? 0. Okay, so GRRA. Load. And then, okay, then we jump down. So something weird has happened to v0. Well, something weird has happened to v0 because I don't know what it is. Then that has infected, or something weird's happened to A2. That's infected v0. And now, we're putting something in A1. So we're getting ready to call another function. Okay. So maybe we have stack corruption and this jump is causing the problem, or something weird happens in Lua close. Okay, so it's in Lua close. I should have stepped into that function. That's unfortunate. That's very unfortunate. Okay, one more time from the top, and then I need to take a break, or maybe call it quits, because this is absolutely maddening. I love it, but I hate it, you know? 268. Okay, now we're gonna load a different elf, and we are gonna step over, step all the way down to this last top. Okay, now we do again this like big step over until we call Lua F close. Now, what happens in here? Okay, move the stack pointer, store some stuff on the stack, copy copy the first argument into the register S5, store S1, load something from this. Well, load, I guess this is our Lua state again, right? And we're like getting a field from it. Save S7. Again, I don't know why like this seems fairly sporadic, but okay. Sub unsigned S1. So what does S1 look like after this? S1. It's weird that we're treating, wait, SP. Yeah. Oh no, hold on. Yeah, no, that's A0. Okay, S1. Sure. So S1 0. We're doing stack manipulation. We're setting up our registers for whatever work we're about to do, right? This is it. It'll be this close up val, right? Frickin' up values every single time. I'm gonna step over this and it's gonna crash. No. Okay, it wasn't the up value. That was a pleasant surprise. Okay. Load immediate. Load word. I just want to find where this is going to go bad, right? So, I mean, branch to an absolute address. I love it. Jal. Oh, this is a big function. I didn't wager on this being quite so big. Okay, we're just gonna haphazardly step over things for now. Get my object? Nope. Lure okay, cool, no yield. It's gonna be this. So what it feels like is we're calling something that's invalid, right? That's simple. That seems to be what's happened. So let's go into draw lure, right? What's actually happening when we call this init? Right, what happens in here? It's a call to set top, right? So it's like at the end of the... Is it at the end? Or is it... Or is it when we call pop? Oh, hold on. Let's think about this stack here, okay? We create a meta table. That doesn't go on to the... That does go onto the stack. Then we create a table. Okay. So our stack has a meta table and then a table. Then we push a C function and we set a field. So we have meta table. And then we push a C function, we set a field. So that has meta table. And then we set... oh, hold on. This isn't right. Oh no, this is right. Yeah. Because then we set the table... Yeah, okay. And then we get that meta table, we pop it off of that stack. So then we make another table. We push a C function, we set a field in that, we set that a global based on the table on top of the stack, and then we pop again. And now we pop out of what we're allowed to pop. And that is no doubt what has caused this crash. Okay, so let's go back to PS2 Lure. I probably would have been much better off just like looking through the logic there before I went into all that assembly diving, but that was kind of fun. I don't know, I enjoy it. Okay, so we build, we come over, we don't need this magic number anymore. It's all gonna change because we're recompiling. Let's just like quickly wipe away this garbage from the screen. We're gonna run our elf. Actually, no, hold on. Whoa, let's chill out. Let's make run. Oh, and there it goes. Boom. We're running, we're rolling. Let's go. Oh, how do we do this? Okay, so PS2 Lure. We need to actually be able to load a file, right? So we need to say let's just copy from what we had in script.h, right? Script.c rather. Lure L load file, Lure P call, blah blah blah. And this is lowercase l. No, it isn't. This is uppercase L, because this is like where we define it. Beautiful. So let's see. Where am I going? I've been playing with Love 2D lately. You can see the muscle memories there. Oh yeah. File. We're just gonna say script init.lure. We're gonna say host script init.lure. We're gonna build file undeclared. Where are we? Oh yeah. Okay. Script init.lure. There we go. So now if we make run, interesting. It does something, it falls through, and it returns. Open name host script. Hey, of course, right? Of course it fails. I haven't made that file yet. So actually, what I want to do is run min.lure instead. Right? That makes a bit more sense. Let's use the file I've actually created. Does this fail again? It does fail again. That's okay. Okay. So if we come back in, we've got to think about what actually goes into this dist folder, I guess. As it stands, I'm guessing we just haven't updated the scripts that are in there, and that is absolutely true. So let's rm dist script example.lua, and let's copy in script min dist script. So let's actually make sure it's there. And now if we make run, it should be able to find it. Okay, so we've got some TLB misses. That's bad. That's pretty bad. But something is actually happening. Unrecognized op. Oof. Oh man. Okay, but we're running. We're running. It's not pretty, but we're running. That's pretty exciting. Okay, so. Let's go into our dist version of the script, because I'm gonna be a bit sloppy, and let's put a print and just see if this actually comes out. Let's like make it a bit colorful so that we can see it in the soup. Also, let's go back to PS2 Lua. Wait, does that mean that this call is failing? Something's failing somewhere. Because otherwise it should loop forever, right? Whatever, let's... Okay, it never reaches that far. Oh man. Okay, well I think that's all I can handle today. This was a mixed stream, right? It had ups, it had downs. This is a pretty weird place to leave it. I'll probably work this out on camera, honestly. But we've got the base of our refactor done, right? The ugliest part of this is done, and actually, I'm going to do something really exciting right now. Let's git add DMA Lua, draw Lua, PS2 Lua. Let's not add our minimal script for now. Git commit working minim. Actually, we need to add the make file as well, don't we? Source commit simple Lua example. I guess working is a bold term, right? Of hardware interface. Not quite working. We've got some kinks to iron out, but we're making progress. Okay, well, this has been delightful. Thank you very much for everyone who's watching. Thank you very much to anyone on YouTube who is plowing through these. I see a few people have been watching them, and it really means a lot. I've been doing basically no advertising. People have just been discovering them. It makes me feel real good. And it makes me feel like, you know, I'm definitely on the right track, and I'm going to continue with this, and I'm going to make something awesome. And it's going to be a lot of fun. It's going to be a long journey, but it's going to be a rewarding journey. So thank you, everyone. Yet again, be sure to let me know if you're enjoying this series. I love to hear that I'm doing things that make people happy, of course. And until next time, I'm Tom. I'll see you then.